Welcome to all of you. Myself Abhinandan Nas. I want to just present about the preparation and the standardization of 0.1 molar sodium hydroxide solution. In this topic, I will discuss about the preparation methods and the standardization of 0.1 molar sodium hydroxide solution, how to prepare and how to standardize. First, this is the contents what I want to discuss in this topic. Next, our main aim. What is the main aim? Our main aim is to prepare and standardize is the 0.1 molar sodium hydroxide solution. Now, you have to know about the standardization procedure. The process of the determination of the precise concentration in the molarity of a solution is known as the standardization. So, for the successful volumetric analysis, a titrant is necessary, that is the standard solution. And if very pure reagent is available, then the concentration is assumed on the theoretical basis. But the titrant is standard against the some primary standard substance. The primary standard substance is a pure substance of the very high stability. Example like the sodium hydroxide, oxalic acid, succinic acid, etc. So first we have to know about the titrate and the titrant, difference between the titrate and the titrant. The titrate is the substance to be determined is called the titrate. In this experiment, the titrate is the sodium hydroxide and titrant is the oxalic acid. The titrant can be defined as the substance of the known concentration, and titration is the procedure of the determination of the volume is called the titration, and end point will be detected at the last of the titration by using any indicator. The indicator is the auxiliary substance that is used to detect the end point of the titration, that is called the indicator. And the standard solution is the known concentration is known as the standard solution. So this is the chemical requirements. Number one is the oxalic acid, then sodium hydroxide and the phenolphthalein indicator. The phenolphthalein indicator produces the violet red color in the basic medium, and there are the colorless solution in the acidic medium. And NaOH will be available in the pellets form, and oxalic acid, the molecular formula is the COOH whole 2, and sodium hydroxide is the NaOH, which was shown in the figure. In the next slide, apparatus required. Which types of the apparatus is required for the performance of these practicals? First is the burette and the burette stand, and pipettes, conical flask, funnel and the stirrer. Burette will be filled up with the NaOH solution, which is known as the titrate, and it will be fixed with the burette stand, and then by using the pipette we can transfer any types of the liquids from one vessel to another, and conical flask will be placed at the lower side of the burette containing the oxalic acid, which is the known as the titrant. And weighing balance will be used for the weight, to take the weight any types of the substance. The main principle behind of this is the acid base titration. The sodium hydroxide NaOH is an alkali whose strength changes over the time, and it can be effectively standardized utilizing the primary standard versus oxalic acid. And sodium hydroxide reacts with the oxalic acid in presence of the phenolphthalein indicator. The color changes from the colorless to the light pink at the end point. Hence, based on the above theory, our aim is to prepare and standardize of the sodium hydroxide solution with the oxalic acid. So now the question is, why does the NaOH solution need to be standardized? To determine the exact concentration, like the molarity or the normality of the NaOH solution, it needs to be standardized. Because solid NaOH is extremely hygroscopic in nature, it should absorb the moisture, so it cannot be precisely weighed. The concentration of the NaOH may be determined extremely precisely by titrating the KHP sample of the known mass or the mole with the NaOH solution. If the mass is taken, then it will be converted into the normality, and mole is taken, so it will be converted into the molarity. So what is the definition of the molarity? Molarity can be defined as the number of the moles of the solutes present in the 1 liter of the solution, that is called as the molarity, which is denoted as the capital M. And normality is the number of the grams equivalent of the solute present in the 1 liter of the solution, that is denoted by the N. It is known as the normality. After that, the reaction COONA will be formed along with the water. Next procedure. First, in the picture we can show that 0.1 m sodium hydroxide solution was prepared by taking 4 gram of the NaOH in a beaker and then dissolve up to 400 to 500 ml of the water, and after that heat will be evolved, so cool the solution, and after that volume will be make up to 1000 ml with the purified water. In this experiment we are performing to preparation of the 200 ml of the NaOH solution by taking 0.8 grams of the NaOH in this conical flask. Next preparation is the 0.1 molar standard oxalic acid solution. In this preparation we can see that in the 250 ml volumetric flask is containing 3.15 gram of the oxalic acid solution. First we have to take wash glass and wash it with the distilled water and dry it. Then weigh the exact amount of the clean and the dried wash glass and record its weight in the notebook. Then we have to take 3.15 grams of the oxalic acid on the wash glass and re-weight it against and check the weight of the oxalic acid is 3.15 gram or not. Using a funnel, transfer the oxalic acid softly and carefully into the wash glass to the measuring flask or the conical flask. Then it will be add the distilled water up to 100 ml, and by using the wash bottle fill up the volume up to 250 ml of this solution by using water into the volumetric flask to prepare the 0.1 molar oxalic acid solution. Next is the standardization procedure. First, burette was rinsed with the normal water and then it will be rinsed with the sodium hydroxide solution, and then it will be filled with the sodium hydroxide solution, and 10 ml of the 0.1 molar oxalic acid solution in the conical flask and add 2 to 3 drops of the phenolphthalein indicator in the conical flask and shake it well. Titrate the NaOH solution against 0.1 molar oxalic acid solution. Now we will discuss about the procedure. First, you can see that the burette was rinsing with the normal water. By opening the cap, stopcock, the water was passed to check about the water passing capacity from its mouth, and after that it was filled up with the water, and water will pass from this mouth into the conical flask. Then in the next procedure we have to fill up the sodium hydroxide solution and rinse the total burette with NaOH solution. Then we have to put NaOH solution and fill up the burette. Then in the conical flask add 10 ml of the solution containing oxalic acid solution containing 2 to 3 drops of the phenolphthalein indicator, that is a phenolphthalein indicator. Then burette was also fixed by using the burette stand, and conical flask was placed at the lower side. Now the titration was started. Drop by drop addition of the drop by drop NaOH solution into the conical flask, which was already contained oxalic acid solution. So now you can see that the color was pink after addition of the drop. So thus titration will be end point will be detected by using the pink color or violet pink color production. So in this method we can now see that the pink color was formed but disappeared after a certain minutes or certain seconds. 2 to 3 seconds after that the color was changed, but color was produced. This process will be continued up to the end point detection, but after a certain time the color will be produced, that will be the pink color which persists in the conical flask. That is the intermediate time when the color was formed but it is not totally in the solution, pink color solution. So after a certain time, now that is the endpoint detection time, now you can see that this colorless solution will be pink after addition of 3 to 4 drops of this solution. You can see that is persist the solution color, which is a pink or violet pink, light pink color. Okay. The volume of the NaOH solution. Now you can see that is the 43.1. So next process is the observation. In the observation we can see that molarity of the oxalic acid was known, that is the primary standard 0.1 molar, and molarity of the sodium hydroxide will be checked. And volume of the oxalic acid solution was the 10 ml. Indicator was used as the phenolphthalein, and end point was detected by light pink color production. And this is the observation table. Each and every time 10 ml of the oxalic acid was taken, and this process was continued for the 3 times. And Boudet reading of the NaOH was the initially 0 ml, and last reading was the 43.1, 43.2 and 43 ml respectively. And the volume is the average volume is the 43.1 by calculating this formula. Now in the calculation parts you can see that M1 into V1 equals to M2 into V2. So M1 is the molarity of the NaOH and M2 is the molarity of the oxalic acid, which was already known. And volume of the NaOH is denoted as the V1 and volume of the oxalic acid was denoted as the V2. So by this formula we can show that the M1 value is the 0.02 M. So we can conclude that from the above experiment, it was evident that the sodium hydroxide can be effectively standardized by using the oxalic acid and addition of the phenolphthalein indicator by helping in the easy acid based titration method of the detection of the endpoints. And so we can result it about the performing the calculation and the strength of the preparation of the hydroxide solution was found to be 0.02 M. And this is the reference from which I have prepared these slides.